Hello everyone, you're welcome to this lesson. In this video, we will be learning about friction. So what is friction? Friction is the force that opposes the sliding motion between two surfaces in contact. When we talk about friction, we have two types. We have the fluid friction and then we have the dry friction. But in this course, we'll be looking at dry friction because fluid friction is tackled in fluid mechanics. When we take dry friction, we have two types, which is the static friction and then the kinetic friction. Okay, so now let's look at something here. So let's say I have a rigid body resting on a horizontal surface. We're going to have the weight force of the rigid body acting downwards, and then we are going to have a normal reaction force opposing the weight force. So let's say I want this rigid body to slide on the horizontal surface, and because of that, I'm applying force P on the rigid body. What will happen is that if P is not high enough, the rigid body will not slide. But that doesn't mean you're not applying any force. We are applying a force, but it is not high enough to cause the body to slide. Okay, so why is P not high enough? P is not high enough because we have another force, which is known as the friction force. And this force will be opposing P. Okay, so when we apply P, this friction force will oppose P. Okay, so as a result of that, the rigid body will not be able to move. That's why I'm saying that P is not high enough to move the body. Okay, that's because the friction force will be opposing P. Okay, and one thing about this friction force is that it increases as P increases, but it has a limit. Okay, so as P increases, F will also be increasing, but F has a limit, and then that limit is known as the maximum friction. Okay, so that's the limit for F, which is the highest magnitude the friction force can have. Okay, so what is actually happening is that when the body is at rest, what will be happening is that if you apply P, F will also increase proportionally. Okay, so let me demonstrate that to you. So let's say I apply force P of magnitude 2 newtons. Okay, F will also increase with that same amount of force, but in an opposite direction. So you see that F has cancelled that P. So because of that, there was no motion. So still P is not high enough to cause the body to slide, because it is being cancelled out by the friction force. Okay, so now that you know about maximum friction, let's say that our maximum friction is equal to 10 newtons in this case. Okay, so I'm going to increase P again. I will increase P to 4 newtons, and then F will also increase in the opposite direction. F will also increase, but in an opposite direction. So I'm going to have minus 4 newtons. Okay, so S has cancelled out P. Okay, so let's say now P is equal to 10 newtons. Okay, F will also be equal to minus 10 newtons. Okay, but at this point you see that F is equal to the maximum friction. Okay, which means that P is also equal to the maximum friction. At that time, we see that we are in the impending motion state. Okay, this is because the applied force is now equal to the maximum friction. Okay, so in this case, I can say that F is equal to Fn, right? So at that point, motion is about to begin. But from all these points, where the friction force was able to cancel out the applied force, the friction force that will be acting at that point is what is known as the static friction. Okay, So what a static friction does is that it prevents an object from what being moved, or it prevents what sliding motion when an object is at what is at rest. Okay, so that's what the static friction does. And as soon as the applied force gets to the maximum friction, what will happen is that if you increase the value of P again, the value of friction is going to what decrease, and then that value of friction is termed as what the kinetic friction. Okay, so if we increase P from here, F is going to what decrease. Okay, and then that friction force is known as what the kinetic friction, and it is considered to be approximately constant. Okay, so that's what will happen. So now let's look at the graph. So let me draw my axis. We're going to have the applied force in this direction, and we're going to have friction force in this direction. Okay, so remember that earlier I said at a point in time, that's when the rigid body is not sliding. If you increase P, F will also increase. We're going to have something like this. It will be 45 degrees. We're going to have something like this. Okay, so if you increase P, F will also what increase. Okay, so we get what the maximum value of what F, which is what the maximum friction, F, right? So from this point to this state where the maximum friction is achieved, we call that the static friction state, or let's say the static state. Okay, we call that the static state. Okay, and then from here, when you get to the maximum friction, what will happen is that the friction force is going to decrease. Okay, and then to become approximately what constant. Okay, so from here we are going to have motion from here. Okay, and then this is what the motion state, or the what motion. Okay, this was the static state. Okay, so from here we are going to have what the kinetic friction what here, and then over here we are going to have what the static friction here. Okay, so let me explain the graph again. As P increases, F also what increases. So what F gets what the maximum value, then from there the friction force will drop to what the kinetic friction. Okay, so at that moment there's still motion. Okay, but friction will be what will be less. Okay, so that's what that means. But when we are dealing with situations where rigid bodies are on horizontal surfaces, we have four different situations that we might come across. Okay, so let's look at those four situations. So let's say I have this rigid body here resting on the surface. Okay, so you have the normal reaction force and then you have the weight force here. So let's look at the first case. Okay, so in the first case, we are going to apply force P in the vertical direction. Okay, so in that case, what will happen is that because you don't have any force being applied in the horizontal direction, you're not going to have any friction force. So with the first case, there is what no friction. Okay, and also there is what no motion. So we're going to have our equilibrium equation to be the normal force equals what the applied force plus what the weight force. Okay, so let's look at the second situation. So in the second situation, what we do is that we apply force P at an angle. So when we do this, what will happen is that P will have components, right? We're going to have P in the y direction and in the x direction. So we're going to have Py and then Px. Okay. So now, because P has an S component, there will be what? Friction, right? There will be what? Friction. This is what the static friction. Okay, so we are using static friction because at this point, with the second case, we consider friction, okay, because the applied force has an S component, okay, but that friction there is not equal to what the maximum friction, okay. So in that case, what there will be no motion, okay, and then we are not even at the state of what impending motion, okay. So for the second case, we are going to have that there will be what no motion. Okay, and then there is what? Friction. Okay, but the friction force, which is what the static friction force, is less than what? The maximum what? Friction, right? And then we are going to have the S component of the applied force to be equal to what? The static what? Friction, right? And then we are going to have the sum of the forces in the y direction to be what? The normal force equals what? The applied force, which is the y component of the applied force, right? Which was Py plus what? The weight force. This is the second case. So let's look at the third case. So with the third case, okay, we assume that the x component, okay, of the applied force equals what? The maximum friction. Okay, so we are in a state of what? Impending motion. That means motion is about what? Begin. Okay, so that's one thing we have. Okay, so at this point, we are going to have the normal reaction force to be equal to Uy plus what? The weight force. Okay, so now let's look at the last situation. So with the last situation, what we do is that there will be what? Motion. Okay, there is what? Motion. And then there's friction, but the friction we have in this case will be what? The kinetic friction. Okay, and then we know that kinetic friction is less than what? The maximum friction, right? And then in this case, it is also less than the horizontal component of the what? Applied force. Okay, so there will be what? Motion. Okay, so we are going to have Fk to be equal to what? The coefficient of what? Kinetic friction times what? The normal reaction. Okay, and then we are going to have the sum of the forces in the vertical direction to what? The normal reaction equals what? Py plus what? The weight force. And over here too, we have the maximum friction to be equal to what? The coefficient of what? Static friction times what? The normal reaction. Okay, and then over here too, we have the static friction to be less than what? The coefficient of what? Static friction times what? The normal reaction. Okay, that's all for introduction to friction. In my next video, we are going to look at the angle of what? Friction. If this is your first time watching our videos and you haven't subscribed, please kindly subscribe to the channel and then turn on the notification bell. See you in my next video.